Hello everyone, myself Rahul. So today I'm going to solve a problem that is also a design problem in itself. So the problem name is LRU Cache. So here we have to design a data structure that allows the constraints of least recently used cache. So if you guys are not aware how least recently used cache was, so I would suggest you to go over this link and have a look at how it is implemented or used. So we have to implement the LRU cache class only, and here we have to implement three functions. So first one is the constructor of the class, in which we are given a capacity as the parameter of that function, and we have to initialize that LRU cache with positive size capacity. Second function is the get operation, in which we are given a key and we have to return the value corresponding to that key. And if the key doesn't exist in that particular class, so we have to return -1. Other function is put, where we have provided key and value. Update the value of the key if the key exists, that's fine. Otherwise, add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. Evict the least recently used key. So that's the main point that we have to consider. Also, one more thing is we have to implement the functions get input in O1 average runtime complexity. Right, so it's a design problem basically, and which we have to construct a class supporting these three functionalities: initialization of the class, get operation, and put operation. So we are given a key value pair and we have to insert that inside some data structure so that we are able to get and update that data structure in O1 average time complexity. So how we can do that? So if we think about all the possible data structures available, like arrays, stacks, queues, heaps, maps as well, right? So only data structure that comes close to implementing this in O1 time complexity is using a hash map, right? Which is nothing but an implementation of hash table itself. So suppose we maintain one hash map of key value. Let me just write it down. So suppose, so before that, let's try to understand the problem, like what they are trying to convey. So we will be given key value pairs. So let's suppose the key value pair is 1, 2, 1, 2. This is key, this is value, and second is 3, 6, 2, maybe -1, and 4, 8. Right, so this is the key value pairs that are given to us, and we have to insert that inside some data structure. Right, and it is also given that the data structure that we are going to create has a capacity of 4. Let's suppose capacity of 3. Right, so initially what we will be doing is, inside the data structure, like any data structure that we are having, it's not finalized what DS we are going to use. So let's suppose v across 1, 2. So we will be checking what is the current size of my data structure. So it is 0 initially, so I will be inserting 1, 2 into that data structure. Then comes 3, 6. So I check whether 3, this key 3 is already present inside the existing data structure or not. It is not present. Like if I check this data structure, only key value 1 is present, 3 is not present, so I will be inserting that 3, 6 over here. Then comes 2, -1. So I check whether 2 is the key over here, right? So I check 2 is present in the existing DS or not. So it is not present, so I insert 2, -1. And then comes 4, 8. Right, so I check whether 4 is present in the data structure or not. It is not present, so I will try to insert it. But it is also mentioned that the size of the data structure or the class we are going to create can have the maximum capacity of 3. So it's 3 is already populated, like 3 elements are already there. So I need to remove some of the elements so that I can insert this new one. So which element I am going to remove from my existing data structure? The one which was least recently used, because it is mentioned in the question itself that whenever we are inserting a new key value, we have to evict the least recently used key. So as I can see, firstly, when the data structure was empty, I inserted 1, 2, then I inserted 3, 6, and then I inserted 2, -1. So what is the least recently used? So what was the last element that I had used, or maybe performed a get operation or performed a put operation on a particular element in this data structure? It was 1, 2. right? So I need to remove this 1 comma 2 out and insert 4 comma 8 over here. So this is the final data structure that I will be having after these 4 operations, right? So these are suppose the put operations. Now if I do a get operation, uh, right, so I need to get value corresponding to key, suppose 2. So I should get value -1 because corresponding to 2 the key value present is -1, right? So I will be returning -1 by looking at this particular map or the data structure. So whenever I perform a get operation, and if I found that particular key inside my data structure, that key is the most recently used, right? So whatever the data structure I am maintaining, I need to somehow also maintain that this is the order of the elements I have encountered till now. So right, so like 2 comma -1 I have most recently encountered, so somehow I need to move this element to the front of this data structure. Like suppose this is an array, I need to move 2 comma -1 to the front of the array, which will denote that this is the most recently used element and this will be the last element to be removed, right? So what I mean to see here is like somehow if we are maintaining the order as well. So suppose this is the current order, 2 -1 4 and 8, right? This is the current order. Suppose this is an array or a vector or somewhat, or maybe any data structure. Now I perform a get operation. So 2 comma -1 is found. So initially the first element was 3 comma 6, right? So whenever I perform a get operation, so this element will get precedence and it will be moved over here. So now this data structure should look like this, right? I have moved to 2 comma -1 to the front of this data structure, which is telling me that this is the most recently accessed element or inserted element. Now if I again do a get operation, suppose get operation of 4, then this my data structure would be changing to this. After doing this get operation, I will be getting value as 8, which I will be returning from my function, and my data structure will look like 2 comma -1 4 comma 8 and 3 comma 6. Sorry, 4 comma 8 would come over here before 2 comma -1. So the order is 4 8 2 -1 and 3 6. So 3 6 has been moved to the end, as you can see, right? It was initially in the beginning, it has moved to the end, which means this element was the least recently used. So if somehow I need to remove some element from this data structure, it would be the last element that needs to go out because this was the least recently used, right? So using a map, as we have seen, won't be able to do all these functionalities, so we have to use some other data structure. So there is only one solution to this problem, like using like to get over time complexity on an average basis for get and put operations, we have to use the concept of doubly linked list over here. So how are we going to do that? I will tell you like the basic algorithm. So in this, the concept is we will be maintaining two nodes, head and tail, right? And between these elements, whatever the elements are present here between head and tail, this has to be the capacity of the linked list, right? And it will be a doubly linked list, DLL. Like we will be having previous pointer as well apart from the next pointer for a particular node. So whenever I am inserting a new element, suppose I am doing a put operation with key and value, I will always be inserting that element next to head. Suppose X is the element that I am going to insert, so I will be inserting that element at the position just after head. And if I'm suppose this is the linked list that has been created after doing all these operations. Now I want to do a get operation for a particular key. So suppose the values inserted are 1 comma 2 3 6 4 8 2 -1, right? So now I need to do a get operation of 4. So also apart from this linked list, I will also be maintaining one map as well, it is nothing but a unordered map because we want the complexity to be of 1, right? If I use a ordered map which is internally implemented as a BST or a binary tree, so the complexity would actually move to log of n, which we don't want. So that's why we will be using unordered map, which is internally implemented as a hash table itself. So in the unordered map, what will be the key and value? Key would be the key same as the one given in the question itself. So key would be 1, 3, 4 and 2. These values, basically the first 1, 3, 4 and 2, and the value for them would be nothing but the complete node itself, this node, these nodes as well, right? What is the purpose of maintaining this map? So somehow if you want to do a get operation, like I want to see what is the value corresponding to the key 4, so I need not look at the complete linked list, and I will just look into the map in O of 1 time, and corresponding to key value 4 I will be getting one node, and for this node I will be getting its value, right? Simple only, right? So yeah, I was on this get operation. So suppose I want to do a get operation. So what are the things I have to do? I will first see whether this key is present in the map or not. Yes, it is present. Then I will basically directly return this node. And one more thing I have to do is, so I will just write down what are the things I have to do in the get operation. I will look into map whether this key is present. If it is not present, I will return -1. If it is present, then I need to do some steps. What are the steps? So whenever I access some element, right, so that becomes the most recently used element. So in that case, I have to move that element to the front of the linked list. Why are we doing that? So basically the concept, the intuition here is like in the linked list, the first element, by first element I mean the element present next to the head. So head and tail over here actually are nothing but the dummy nodes which won't be holding any key values. So they are just created so that we are able to identify what is the beginning and end of the linked list, right? So whenever we encounter a new element or we do a get operation on a particular element, we move it to the position just after head, like over here. Why are we doing that? Because the element present are present in such a way that this is the head, this is the tail. So element present just after head denotes that this is the most recently used element, and element just after this element would denote this is the most recently used element just after this, right? And whatever element is present just before tail, it will tell me that this is the least recently used element. Like this element hasn't been there has no be insert element, insert operation or put get operation on this particular element, right? So whenever I need to remove an element from this linked list, I will just remove the whatever the element is present just before tail. This element I am going to remove because this is the least recently least recently used element. So if we draw a graph, like, right, so in this size, like in this direction, least recently used element actually are the elements. So this one is the most recently used element. This one is a little less most recently used element, and this one will be the least recently used, right? So let's I will go through the code as well. So let's see like what are the functions we have to implement, and how we have implemented those. So there are a lot of edge cases that we have to handle in this case. So firstly, I have created one node variable. In this I am going to store key and value both, and the previous and next pointer. So this next is used because we want to use the doubly linked list. And I've created two dummy nodes, head and tail, and two variables, size and cap. So size is going to tell me, this variable size is going to tell me what is the current size of my doubly linked list. And this cap is nothing but the capacity of the linked list, which will be initialized at the calling of constructor. So where is the constructor? Now this is the constructor. So here we are passing the capacity. So whenever the constructor is called at the initialization of the class, this will be called actually just only once. So here we are creating head and tail nodes, and the head next will be created as tail, and tail previous would be head. right? So there will be just two nodes in the linked list, head and tail. So head next is tail, tail previous is head. And the size of the linked list, the current size of the linked list is 0, and the cap variable, which denotes the capacity, the maximum number of nodes a linked list can hold, has been initialized to the capacity variable, right? So this is regarding the constructor. Now the other operation we have to perform is the get. So before get, let's move to put operation. So this is much simpler. So in the put operation, we are given a key and value, right? So whenever we want to insert into the linked list, we first need to see whether that key is already present in the linked list or not. But searching in the linked list would take actually of n time. So that's why we have created a map at the top, unordered map of intent node star, right? So I'm basically checking whether this key is present in the map already or not. If it is already present, right, so I just need to update the value of that particular key. So x value would be updated as whatever the new value I have received in my function call, right? And one more operation I need to do is move to head. So I explained you like why whenever I perform a put operation, that element or that key becomes the most recently used. Like this is the most recently one key that I have used, right? So I have to move that key to the beginning of the linked list, which will denote that this will be the key which will be removed from this linked list in the end, right? So if I suppose, suppose this is the linked list, right, with the previous pointers as well, right? So suppose I do a get operation on this particular element, and this is holding value, suppose 1 comma 2, right? I do a get operation on key 1, and somewhere over here are head and tail. This is head, this is tail, this is head over here, and this is tail, right? So whenever I do a get operation on this, I need to remove this element from here and move it to the front of the linked list just after head, right? So I'm basically increasing its priority. You can, if you can relate it to the priority queue somehow, right? So I have written a move to head function in which I'm passing that node, and in this move to head function I will be moving that x node to the front of the linked list, right? So this was the case when the key was already present inside our map. If the key is not present inside in our map, which means this is the first time this key has been encountered, so we need to create one node. So create node function I have written, in which I am passing the key and value, and it will just return me a node created, right? And one more thing I have to check here is, like, if I am inserting a new element, right? So I have to insert that new element, but I need to check after inserting whether my size of the linked list exceeds my capacity or not. So I'm over here checking, like, if the size is less than cap, which means that I can accommodate my new element into the existing linked list. Like my size is not exceeding the maximum capacity my class can have, right? So here I'm just checking if the size is less than cap, so I just increment the size variable. But if the linked list was already of the maximum size, right? So suppose this is head, this is head over here, this is tail, these are the elements 1 2 3 and 4, right? So suppose the size of the linked list was 4, maximum size capacity of the linked list was 4, size is 4, capacity is 4, and now I do a put operation, right? So at this particular time I need to create this variable and insert it at the head of the linked list. That's not a point. So the other thing is I need to remove the least recently used element as well, and the least recently used element would be nothing but the last element in the linked list, which will be just before tail. So I will be removing this element and inserting this element over here, so the number of elements now is 1 2 3 and 4. This element will be removed, head and tail are not counted, right? So that's what I have checked over here. If the size is greater than or equal to capacity, I need to remove the tail. By removing tail, I mean the element present just before tail, right? So this is the put function, and what we have to do inside the get function is, inside get we are just passing the key for which we want to get the value, right? So for this, firstly I need to check whether this key is present in the map or not. If it is not present, which means in that case I have to return -1, because in the question itself it is mentioned that we have to return -1 if the key is not existing in the class, right? So I'm returning -1, but if the key is present, I need to return whatever value. Like I have a map over here, right? So I have two uh, possibilities over here, not possibilities, two ways in which I can return the value for a key. I can look into the linked list for that particular key, what is the node, and I will get the value corresponding to that particular node from the linked list itself. But iterating over one by one node in the linked list itself would take off n time, and we have to make this operation of 1, right? So we will use the existing map that we have created. So we will just get mp of k, which will tell me what is the node associated with that particular key, right? And I finally have to return x value corresponding to that particular node. But whenever I am doing a get operation, right, so it means this will become the most recently used, not least one. It will become the most recently used. So I have to move this node to the front of the head so that it will be the last element, or maybe like this node will get a priority over other elements, right? So we have to move this complete node to the head of the linked list. So that's why I've written this move to head function over here as well. Right, so let's go to the utility functions like move to head, remove tail, like how these are implemented. So these are simple only. Print list function I've implemented just for debugging purpose. We can ignore that. And let's go through the first create node function. Yeah, create node function is very simple. So we are just passing key and value, and I'm using new node, and x key has been given the value k, value has been given the value v. And whenever I'm creating a node, I need to create that node at the head of the linked list. By head I mean just after head, head node, right? So I need to update these next pointers. So if I try to explain like what this denotes, so just give me a second. Yeah, so like suppose this is the head and this is the tail, and these were the existing nodes in this, and now I need to insert a new element. So this is suppose value x, right? So I need to insert this x over here. These links would already be in place, right? So how do I make this place over here? So I need to make the next pointer of head pointing to x, and the next pointer of x would be pointing to this, and the previous of this would be pointing to this, and x previous would be pointing to head. So there are 4 pointers that I need to update. So that's what I'm doing over here. And also I need to update the map as well. So I'm inserting the value k inside the map, and the value would be nothing but complete node itself, which is x. And how I'm going to move it to head? So I'm given a node x and I need to move it to the head of the linked list. So firstly I will check whether it might be the case that x is already present at the head. So I'm checking if head next is already x, right? It means it is already at head, so I don't need to do anything, I will return. But if it is not the case, I need to make some pointer changes. So that's what I am doing over here. So if you try to draw a linked list and go through like what each step is doing, so you will be able to understand these. Remove tail. So remove tail function would be called whenever we are exceeding the size of the linked list and I need to remove the least recently used one, and the least recently used one would be the element just before tail. Like, but I have named it remove tail, but it shouldn't be an issue. So how I am going to remove it? Yeah, let me show you. So suppose this is head, this is tail, and this is head, this is tail. Change the color, and these are the nodes, right? So I need to remove this element. So for this element to be removed, I need to make what are the links I have to change. So these next and previous links would already be in place, so I just need to make these changes. Like the next pointer of this node, the one previous to this, I have to be made as tail, and the previous of this has to be made as this. That's it. Right, so I am just I just need to make two pointer changes. Like the first one is like the next pointer of this node has to be made as tail, and the previous pointer of tail has to be made as this node. So that's what I have done over here. These two pointers, or the previous and next pointers, have been changed, and also I need to remove that particular key from the map as well, so that we don't get it whenever I do a get operation, right? So I need to update the map as well. So yeah, I guess these were the functions. It should be fine. Let me try running it. This is fine. I will submit it. Earlier I had tried, but it was giving wrong answers. This time it should be fine. Yeah, runtime memory usage all looks perfectly fine. So it is a very good example like how we have used hash map, doubly linked list in a design problem. So actually this problem is also asked in the design interview questions, and the interviewer may ask you to design this class and develop or design the functions get input in such that they are in O1 operation time, right? So it's a very easy problem, or I would say very challenging problem as well. So I would recommend you to code it yourself first, step by step. Like try to see what are the edge cases we have to cover, like in the put operation, right? So we have to check whether the key is already present in the map or not. If it is already present, then we need to insert it. When we are inserting, whether we are exceeding the size of the data structure or not, right? So these cases has to be handled gracefully, and yeah, I hope like you understood the solution. So if you have any queries, please do comment, and I will see you next time with another problem. Thank you everyone.